In the previous R4a, we started taking a look at adding and subtracting fractions. And remember, the big thing to remember is you cannot even think to add or subtract fractions unless you have common denominators, because you can only add and subtract like things in math. So I'm going to do a few more details to show you how to find those common denominators. So let's take a look at the problem. Three-fourths plus, and I'm going to stick with three fractions because I just feel like doing lots of work here, plus 5/6 plus 2/9. Clearly, we can't add them as they are now because we're not adding like things. So what we're going to do is we're going to try to change each of these three fractions to an equivalent fraction in which they all have the same denominator. So over here on the side, I'm going to write what we're doing. We're finding the least common denominator. And if I tell you, you already know how to do this, because the least common denominator for these fractions is always the LCM. Remember R2, R2, the least common multiple of those numbers. So, remember how to do that? We take our three numbers and we tear them apart using branch factorization to see what they're made of. 4, 6, and 9. Get to the punchline here. We can see, as we now know how to find the LCM, which is the LCD in this case, we would have to need 2 2s and 2 3s, and when we multiply those out, we would get 36. So let me create some space here. That means what we're going to see on all of our denominators, there we go, are 36, 36, 36. So do you recognize we are changing this first fraction to another fraction equivalent but looking differently? We know we can do anything to a fraction if we multiply the top and the bottom by the same number, or if we divide the top and the bottom by the same number, we're going to get an equivalent fraction. So since we've already changed one piece of that fraction, namely we went from 4 to 36, we have to ask, well, how did we change it? What did we multiply 4 by to get 36? And I'm going to do this in red in a slightly different way than I did it previously. I go, okay, 4 times what gives you 36? 4 times 9. So that's our marching orders. That tells us how we want to change the numerator. So we're going to take the numerator and also multiply it by 9. 3 times 9, let's keep that in blue, 27. Same thing for 5, 6. What did we do to 6 to get to 36? Well, we would have to multiply that times 6, so that tells us we're going to multiply that 5 times 6. And we would get 30. And then to finish this off, 9 times what gives you 36? 9 times 4. So you know you're going to have to take the numerator times 4, and you would get 8. Once you've done that, pretty much you've done most of the work there. So what's going to be our denominator and answer? Right, 36, because you're just adding 36s like you can add dogs, so you end up with 36. To get the numerator, you just say, well, how many of those 36 do I have altogether, and what does that look like? About 65. And we always want to check, can we go any further and reduce that? So this is the correct answer, but it may just not be finished yet. So remember, we've got to do that last step to see if we can simplify this. So I'm going to take that 65 and I'm going to use prime factorization because I'm in love with prime factorization. It makes life so much easier for it. If I tear that apart, I would get 5 times 13, and 36, I would get 2 times 2 times 3 times 3. Bummer. Nothing cancels, so we go, all right, we did all of the work we could. That's our final answer. Okay, I want to do a few more examples. Okay, let's just go to 2 fractions this time. 1/3 minus 2/15. So we've just got two fractions and we're subtracting them. We need, because we can't subtract them now, we need the LCD, which again is just the least common multiple of 3 and 15. So I'm going to write those 2 numbers down, tear them apart. 3, well, that's 3. 15 is 3 times 5, so our LCD would be 3 times 5, or 15. So I know I'm going to have 2 fractions here, each with a denominator of 15. I tell you what, I'm going to volunteer and do the second fraction, because we didn't change the denominator, so we don't have to change the numerator, so that just stays 2/15. But in the first fraction, yeah, we changed that denominator by multiplying by 5, so that tells us we have to change the numerator by multiplying times 5. So we would get 5/15. And then once we have common denominators, we can combine those, and our answer is going to have a denominator of 15, and our numerator just comes from 5 minus 2, 3. Oh, I hope we can simplify this. So I am going to put a circle around that so I don't lose it. Tear that apart. 3 can't be torn apart anymore because it's prime. 3 times 5 for 15 in the bottom. Oh, yippee, we get to cancel here. Divide by 3, divide by 3. What do we have left over? Okay, because there's nothing left on the top when we cancel out that 3. So do you remember when I said when we cancel, we're really dividing? So 3 divided by 3 is 1, and 3 divided by 3 down here is 1. So keep that in mind. If there's nothing left in the numerator, what you've just got really is a 1. So 1/5 is our final answer, and we'll say, put a double circle around it and say that's our final answer. Okay, I think I will stop and go on to the next video for some more examples.